Hello everyone and welcome to AWS Storage Services Selection or Decision Guide Part 1. This is one of the most important lecture of the entire course. I will go as far as saying that if you watch this lecture completely and pay attention, then you will most likely be able to answer all the storage related questions. Most exam questions will ask you to pick the right storage service or will try to confuse you or trick you into choosing between similar storage services. So if you go through this lecture, then hopefully you will be able to tell the differences or similarities between these storage services clearly. So this lecture will contain all these topics: service category, primary function and purpose, main access methods. Next, deployment complexity and management effort, scalability type and scalability limits, latency characteristics, IOPS capabilities and throughput capabilities, durability level, availability design, and recovery time objective and recovery point objective RTO RPO, primary cost drivers, pricing model and cost optimization strategies. So the services which I will be covering are Amazon S3, Amazon EBS Elastic Block Store, Amazon EFS Elastic File System, Amazon FSx for Windows, Amazon FSx for Lustre, Amazon FSx for NetApp ONTAP, Amazon FSx for OpenZFS, Amazon File Cache, AWS Backup, AWS Data Sync, AWS No Family, Storage Gateway, and AWS Transfer Family. So the first set of parameters will be service category, what is the primary function and purpose of the service, and main access method. So first we have Amazon S3. So the category it belongs to is object storage. Function, it is a scalable storage and retrieval of objects, and these objects can be files, backups or media. Access methods will be common across all the services, which are API, which are REST based, console, AWS console user interface, CLI, command line interface, SDKs, and SQL for S3 tables. Next, Amazon EBS, it is a block storage. Main function or the purpose is to provide persistent block level storage volumes for EC2 instances. Access type is it's a block device which is attached to EC2. Access methods are console, CLI and API. Next, Amazon EFS, the category it belongs to is file storage. Main function is it provides a scalable, elastic, shared NFS file system for Linux based workloads. Access types or main access methods are file system mount through NFS v4 protocol and access via AWS console, API and CLI. Next, Amazon FSx for Windows. Category is file storage. Function, it's a fully managed native Windows file system and it offers SMB protocol, NTFS and AD integration support. Access types are file system mount through SMB and you can access via console, API and CLI. Next, we have Amazon FSx for Lustre. Category is file storage. Function is high performance file system optimized for high performance computing, HPC, machine learning, analytics and media processing. Access type is you use Lustre client mount and you can access it via console, API and CLI also. Next, we have Amazon FSx for NetApp ONTAP. Category is it is a file storage. Function, it provides fully managed NetApp ONTAP file system with rich data management features. Access, so you can access via file system mount and it supports NFS, SMB, iSCSI, NVMe, OTCP protocol and you can access via API also. Next, we have Amazon FSx for OpenZFS. Category is file storage. Function, so it's a fully managed OpenZFS file system with features like snapshots, cloning and compression. Access, so you can use you will usually use file system mount which is based on NFS protocol and you can directly access via AWS console, API and CLI. This is for admin tasks. This is for common across all the services. Next, we have Amazon File Cache. The category it belongs to is high speed cache. The main function or the purpose is to provide temporary high speed cache for file data stored in S3 or on premises or in cloud NFS. access, you will use Lustre client mount client mount, and you can directly access via console, AWS console, API and CLI. Next, we have AWS backup. Category is backup and recovery. Function, it provides centralized automated data protection across AWS services and hybrid workloads. So you access it via AWS console, API and CLI. Service, next service is AWS data sync. The category is data transfer or migration. Main primary function is online data movement and discovery between on-premises / cloud and AWS storage. You access it via data sync agents and directly access via AWS console, API or CLI. Next, we have AWS No family. The category it belongs to is data transfer or edge compute. Function is offline data transfer, which can be petabyte scale also, and edge compute or edge storage capabilities. Access is via physical device. So in this case, it's a direct physical hardware device, and there is a tool software called OpsHub also, which you can use to access the interface, and then you can use CLI, S3 adapter or NFS. Next, we have AWS storage gateway. The category is hybrid storage. Primary function is to connect on-premises applications with AWS storage using standard protocols. You access it via NFS protocol, SMB, iSCSI, VTL interface and console or the API. Next, we have AWS transfer family. The category it belongs to is managed file transfer. Primary function is to securely transfer files directly into or out of S3 or AFS using SFTP, FTPS, FTP and AS2 protocols. Access is via, so these are the protocols which support, and you can access it via these protocols: SFTP, FTPS, FTP and AS2 clients. So there is a client which you can use for accessing the service, and you can directly access via console, API, CLI and also web apps. So next set of parameters will be deployment complexity and management effort for all the storage services. So first, S3, it's a simple deployment. So deployment complexity is simple. You basically create bucket, upload files, and the management effort is low. It's a serverless service and it auto scales, and it provides managed features like lifecycle management. Next, Amazon EBS. So deployment complexity is simple. You create volume and attach to EC2. Management effort is medium, and the tasks involved are resizing volumes, managing snapshots and monitoring the performance. Next, Amazon EFS. Deployment complexity is simple deployment. You create file system, mount NFS, and management effort is low management because it's a serverless. It auto scales storage and throughput in the elastic mode. Next, we have FSX for Windows. Deployment complexity is moderate deployment complexity, and some tasks involved could be AD integration, share configuration. Management effort is medium management. So patching is managed by AWS, and user will manage the shares, quotas and AD configuration. Next, Amazon FSX for Lustre. Deployment complexity is moderate deployment. It requires Lustre client installation. Management effort is medium management, and so patching is managed by the AWS. User manages performance tuning and linking with S3. Next, FSX for NetApp ONTAP. Deployment complexity is moderate to complex deployment. So you need to know about the ONTAP concepts and configuration. Management effort will be medium to high management, and patching is managed by AWS. User will manage the ONTAP features, SVMs and volumes. Next, we have FSX for OpenZFS. Deployment complexity is moderate deployment. So you need to do NFS setup, volume / snapshot configuration, and management effort is medium. So patching is managed by AWS. User manages the ZFS features, volumes and quotas. Next, we have Amazon File Cache. Deployment complexity is simple to moderate deployment. So you create cache, link repositories and client install. Management effort is low. And basically it's a managed cache eviction and monitoring. So these are the tasks which we have to do. AWS backup. Deployment complexity is simple. So you define backup plan, you define vaults, and you assign resources. Management effort is low, low management, and basically the other task involves are centralized monitoring, compliance, and automated lifecycle. Next, AWS data sync. Deployment complexity is moderate deployment, and the tasks could be agent deployment and activation and task configuration. Management effort is medium management, and the tasks are monitoring task status, network performance tuning. Next, AWS No Family. So it's a complex deployment, and the tasks are basically you have to order the physical device setup, network configuration, and Ops Hub installation, and working with Ops Hub software. Management effort is high management. So basically you have to do physical device handling, shipping, local compute, and storage management. Next, AWS Storage Gateway. So it's a moderate deployment complexity, and the tasks are VM hardware setup, network configuration, and activation. Management effort is medium, and the tasks are monitoring health and performance, updates, and cache management. Next is AWS Transfer Family. Deployment complexity is simple to moderate, and the tasks are server endpoint setup, IDP configuration. Management effort are low to medium management effort, and the tasks are monitoring usage, user management via IDP service. And next set of parameters will be scalability type and scalability limits. So first, Amazon S3 scaling is horizontal and it's automatic. And some limits and performance. So there is virtually unlimited objects and storage, which can be in exabytes. For a single object or a file, let's say, the single file or object, we just have to remember this is a 5 terabyte. There is a limit only on a single file. And it supports up to 2 million transactions per second for the directory buckets. Next, Amazon EBS. Scaling is vertical, so it's horizontal is it can unlimited. Vertical is basically same machine you can go upwards, in the sense you can increase the CPU or RAM or storage. So it's vertical and it is based on per volume, and you can do manual or through API resizing. So some limits are 1 GB byte to 64 TB byte, which depends on the type. So when you create EBS volumes, you will choose the type. And IOPS / throughputs may vary. For example, there are two types like IoT IO2B will have 256,000 IOPS and 4,000 millibytes per second. So depending on the type, it may vary. Next, elastic file system. So scaling is horizontal and it's automatically taken care. And some limits are so it's a petabyte scale storage. And the throughput is in GB per second, which is gigabyte per second. It depends on the mode or the region dependent. There is the IOPS limits which exist. For example, 500,000 write is the default. Next, Amazon FSx for Windows. Scaling type is vertical. It depends on per file system, and you will do a manual or API resizing is possible. So some limits up to 64 TB byte storage, up to 12.2 GB per second is the throughput, and up to 400,000 is the IOPS. And you can have a maximum 100,000 shares per file system, and there are some limits which exist for AWS accounts. Next, we have Amazon FSx for Lustre. Scaling is horizontal. It scales automatically with storage. Sorry, it not automatically. It scales with the storage, like how much storage you have chosen for. And limits. It's a petabyte scale storage. It offers up to 1 terabyte per second throughput. IOPS is in millions input output, and there are some account limit which exist. For example, there can be 100 file system per AWS region. Next, Amazon FSx for NetApp ONTAP. Scaling, so there are two types, both vertical and horizontal. So you can scale SSD, you can scale throughput, or you can have a high availability pairs, and some limits up to 1 PB. So that is the storage limit for single AZ Gen 2. There is a version, and throughput can be up to 73 GB per second. IOPS can be up to 2.4 million transactions per second, and you can have up to 500 to 1000 volumes per file system, and there may exist some limits as per your AWS account. Next, we have Amazon FSx for OpenZFS. Scaling is vertical, so you can scale the SSD, throughput and IOPS. Storage immutable post creation. So basically you cannot change once you have to create, and that time it will be fixed. So there are limits like up to 512 TB storage, throughput up to 10 GB per second disk throughput, 21 GB per second compressed, and IOPS is up to 2 million IOPS. You can have 100 volumes per file system. Next, Amazon File Cache. Scaling is horizontal. It's a managed scaling from AWS. Limits minimum 1.2 TB cache storage, up to 1000 Mbps throughput, or Mbps for every TB throughput. It offers millions of IOPS, and there may be some account limits which exist. So you can have up to 100 caches for every AWS region. Next, AWS Backup. Scaling is horizontal. It's a managed service, so it horizontally scale. Limits, so it's a exabyte scale storage. High limits on vaults, and high limits on vaults, plans and jobs per account and per region. Next, AWS Data Sync. Scaling is horizontal, and because there is an agent which we have to install, so you can have multiple agents to improve the scaling. So it will horizontally scale if you install more agents, right? And limits, it can offer up to 10 Gbps for every task. So that depends on the agent. For every task, you can have up to 50 million files per task, which is in the basic mode, and this can be adjusted. And you can have up to 100 tasks per AWS account, which also can be adjusted. Next, AWS Node family. Scaling is horizontal, so you can have multiple devices. So similar to previous one, you can have because we can physical devices there, so we can horizontally scale it. So limits, device capacity limits. For example, so depending on which, like it can be Snow Mobile, Snow Cone. So depending on which one you have ordered. For example, for the storage optimized, the device storage is 210 terabytes. And job limits depend on the data size and how many parts you divide into. Next, storage gateway. Scaling is vertical, and that depends on per gateway instance. So limits, cache up to 64 TB. You can have maximum 32 volumes per gateway for the volume gateway type. Max 1500 tapes per gateway for tape gateway. Throughput depends on the host and the network, because you have to install something and use some hardware on your data center, so it depends heavily on the network being used and the host on which you have installed the appliance. Next, AWS Transfer family. Scaling is horizontal. It's a managed auto scaling. Limits, high scale. So for example, 10,000 concurrent sessions as mentioned in the documents, and specific quotas exist. For example, SFTP connector queue depth and bandwidth. So this is very specific to the service itself. So next set of parameters are latency characteristics, IOPS capabilities and throughput capabilities. So first, Amazon S3. So latency is low. It is in millisecond for standard and express, and higher for minutes to hours for something like depending on the tier. So Glacier have higher latency. Throughput is high aggregate throughput, transfer acceleration available. So this service has this transfer acceleration feature. And IOPS per rates, high request rates. So millions of transactions per second for express. Next, EBS. Latency is very low, single digit millisecond for SSD, but bit higher for hard disk drives. Throughput up to 4000 megabyte per second. So for this type is IoT IO2BE, and 1000 MB byte. So depending on like GP3 and ST1, so they have different types of throughput, and IOPS up to 256,000 and 16,000 for GP3 and 500 for standard ST1. So depending on the type, they have different throughput and IOPS. Next, EFS. So latency is sub millisecond for general purpose, but bit higher latency, millisecond for max IO, because it will do more IO, so it has bit higher latency. And throughput, it is GB per second per file system, and scales with data and the mode. And IOPS, it can offer up to 500,000 plus, and it scales with the data or the mode which we have chosen. Next, Amazon FSx for Windows. Latency is low, it is sub millisecond. Throughput up to 12.2 GB per second per file system. IOPS up to 400,000 IOPS per file system. Next, FSx for Lustre. Latency is low, sub millisecond. Throughput up to 1 terabyte per second per file system. IOPS, millions of IOPS per file system. Next, Amazon FSx for NetApp ONTAP. Latency is low, sub millisecond. Throughput up to 73 GB per second per file system for the Gen 2. And IOPS up to 2.4 million IOPS per file system. Amazon FSx for OpenZFS. Latency is low, hundreds of microseconds. Throughput up to 10 GB per second and 21 GB per second for cache or the compressed type. IOPS up to 400,000 for the disk and 2 million cache IOPS. Amazon File Cache. Latency is low, sub millisecond for the cache data. Throughput up to thousands of GBs per second per cache. IOPS, millions of IOPS per cache. AWS Backup. So latency, IOPS, throughput not applicable. AWS Data Sync, again latency not applicable. So it focuses more on transfer speed, and throughput can be up to 10 Gbps per task because we use an agent in this case, and IOPS not applicable. AWS No Family, latency, throughput, IOPS not applicable. Storage Gateway, latency low for the cache data and higher for the if you are doing a cloud retrieval. Throughput depends on the gateway configuration, network, and the backend storage. IOPS depends on the gateway config, network, and the backend storage. Next, AWS Storage Gateway. Latency depends on the protocol, network, and backend storage. Throughput also depends on the protocol, network, and backend storage, and IOPS not applicable. So next set of parameters will be durability level, availability design, and RTO, RPO, recovery time objective, and recovery point objective. So first we have S3. It offers the durability of 99.99. So total there are 11 nines. So we call 11 nines. So this is very high durability. And coming to availability, it has a regional availability, and by default the data will be stored in 3 availability zones. So there is a very high unlikelihood or I can say very low chance of losing any of your data. And you have single AZ option also, so you have to choose either one zone or express. But default is regional, so data will be stored in 3 AZs. And RTO, RPO, so recovery point objective. So recovery point means how much data you will lose. So RPO depends on the versioning, whether you have gone for versioning or the replication feature of S3. And RTO depends on the application, how you have configured it. So RTO is recovery time. So how much? So one is like the size of data and how long time is. Let's say you take backup every 1 day. So it's possible that you can lose 1 day of data. Next we have Amazon EBS, and this offers a durability of 99.8 to 99.9% maximum, and depending on the type. So most of the time it will be this much, but for example some cases where we have chosen the IO2BE, the durability is 99.999%. And snapshots, it offers 11 nines durability, and the availability for this one is only a single AZ service. So unlike S3, which is multi single region and 3 AZ, right? So this is single availability zone only. And RTO, RPO. So recovery point objective RPO depends on the snapshot frequency. So if you take every 1 hour, that much data only you can lose. So not more than that. And how long? So RTO is meaning how long it will take to roll back. So RTO depends on the restore time and the disaster recovery service, like DRS features of this particular service. Next we have Amazon EFS. This also have a same 11 nines durability, and the availability is it's a regional service and data will be stored in multi-AZ, and there is an option for one zone also, so that will be only single AZ. So you can choose actually. And RTO and RPO. So recovery point objective depends on the how you have set up the backup and the replication. And so how much data will you lose is RTO, which depends on how frequently you do a restore and failover, like how you have set up the restore and failover procedures for the EFS. Next we have FSX for Windows, and it has a high durability, so it's a multi-AZ replication. Availability is single AZ or multi-AZ, both options are there. And RTO and RPO. So RTO is less than 60 seconds for multi-AZ failover. So as soon as one AZ fails, it will take only less than 60 seconds to failover to the other one. So let's say you have 3 and 2 of them goes down or 1 of them go down. It can failover to other one in less than 60 seconds. And recovery point objective, which is the data, right? It is near zero because the sync is multi-AZ sync. So near zero means almost none. The data is being synced. Let's say you have 3 AZ, so data is being synced across 3 AZ synchronously. So there is all near zero data loss. And next one is FSX for Lustre. So durability is high, and it's a persistent replication within AZ. Okay, so there are 2 modes actually. So for FSX for Lustre, there is a scratch mode and the persistent mode. For the persistent mode, the durability is high because its data is replicated within AZ. For low, durability is low. So basically, scratch is like use and throw. Like you don't want something valuable, and you can use scratch like a scratch mode. And availability is single AZ. So both options are there, persistent or scratch, only single AZ. This is a single AZ service similar to EBS. It's not a regional service. And RTO, RPO. So RTO is in minutes, so persistent replacement. And RPO, how much data you can lose is depends on the how frequently you have backups and S3 sync for the persistent mode. So both is persistent mode only. So FSX for NetApp ONTAP, so durability is high. It's a multi-AZ sync replication, synchronous replication. Availability, you can go for single AZ or multi-AZ. Coming to RTO and RPO. So RTO is recovery time objective is less than 60 seconds. Multi-AZ failover. So it will take as soon as one AZ goes down, it will take less than 60 seconds to failover to another one. And RPO is near zero because again same, a multi-AZ have a synchronous replication setup. FSX for OpenZFS, durability is high, multi-AZ sync replication. Availability is single AZ, and you have high ability and non-HA setup. And multi-AZ, you have HA setup. RTO, RPO, again same. RTO is less than 60 seconds for HA failover. And RPO is near zero because multi-AZ synchronous replication. Amazon file cache, durability is high, disk replication within AZ. Availability design is single AZ. So this is again single AZ service similar to EBS. It's not a regional service, so data will be only in one single availability zone. RPO is RTO minutes. So server, it's in minutes. Server replacement you have to do. And RPO depends on the export frequency. So how frequently you export, that much data only you will lose. So if you export every 1 hour, that much maximum you can go. If you do in every 10 minutes, maximum that much is the 10 minutes of data you will lose. Okay, AWS backup, durability is high, and this inherits backend S3 durability. because the backend is S3, so that whatever that durability is same as this AWS backups durability. Availability, so it's a regional service. You can have cross region, cross account copy support. RTO, RPO, so it depends on the source service, backup frequency, and restore process. Next, AWS data sync. It has high durability, which is ensured by data integrity checks. Availability, it's a managed regional service. RTO, RPO, so RPO depends on transfer schedule frequency. Next, we have AWS Node family. So durability level, durability is high. So physical device security and erasure. So these are the features. So it has a high durability level. Availability depends on the device. So because we have 2-3 types of device like Snow Mobile, Snow Cone, and Snow Edge. RTO, RPO, relevant. It is relevant for disaster recovery, seeding, and migration, and depends on the shipping / transfer. Next, we have storage gateway. Durability is high. It inherits the backend, which can be S3, EBS, and FSX durability. So backend is supported by these three for the storage gateway. And availability, it's a regional service, and there is a HA option for VMware. RTO, RPO. So RTO is around 60 seconds with HA failover. And recovery point objective, how much data you can lose, it depends on the cache state, snapshot, and backup frequency. AWS transfer family, durability is high. It inherits the backend, which is to either S3 or EFS. So whatever durability they offer, transfer family will have the same durability, S3 or EFS. And the availability is a managed regional service with auto scaling. RTO, RPO, so generally low due to managed service and backend durability. And last set of parameters will be primary cost drivers, pricing model, and some cost optimization strategies. So first, S3, primary cost drivers are storage, how much storage in terms of GB, gigabyte, and by class. So we have different class like general purpose, Glacier, and all. And how many requests, data transfer out, and depending on the feature, like tiering, monitoring, so you will pay as per those. Pricing model is tiered, pay as you go, and that is per GB and per request. Cost optimization strategies are choosing the storage classes, lifecycle policies, intelligent tiering, compression, monitoring. So depending on which features you have opted for, you will pay accordingly. Next, EBS. Primary cost drivers are provisioned storage, the total GB size, provisioned IOPS and throughput for IO and GP3 types of EBS volume, right? And snapshots, how much snapshots are there in the data stored GB, and features like FSR, direct APIs. And the pricing model is per GB per month, per IOPS per Mbps per month, and per DSU hour. And cost optimization is type of volume that you select, GP3 baseline performance, snapshot lifecycle archive policies or process you have in place, and right sizing the right type of EBS. So that's how you will optimize your cost. EFS, primary cost drivers are storage GB, and we have standard, infrequently access, and archive, and data access, provision throughput, which is optional, and backups. Pricing model is pay as you go for storage and elastic throughput. So there are two types, storage and elastic throughput, and provisioned throughput. Cost optimization depends on lifecycle management, to infrequent access or archive, and throughput modes, which can be elastic versus provision, and lastly storage classes. FSX for Windows. Primary cost drivers are storage GB, and this have SSD or SDDD hard disk drive, and then throughput capacity, SSD IOPS, which is optional, and backups and data transfer. Pricing model are provision, and this is based on per GB, per Mbps, and IOPS month. Optimization strategies are storage type, which can be SSD, SDD, data deduplication, single AZ versus multi-AZ, and right sizing. So these are the cost optimization strategies. Next, FSX for Lustre. Primary cost drivers are storage GB, and that can be in SSD or HDD. Throughput for per TB byte, metadata IOPS, backups, data transfer. Pricing model is provisioned and per GB per Mbps IOPS per month. Cost optimization strategies are choosing the storage type, deployment type which can be persistent or scratch, compression and quotas. SSX for NetApp ONTAP. So primary cost drivers are SSD GB, IOPS capacity, pool usage which is GB plus request, throughput capacities and backups. Pricing model are provisioned for SSD, IOPS and throughput plus pay as you go, which is part of a pool of FSX for NetApp ONTAP. And cost optimization strategies are storage tiering, so SSD to pool, compression deduplication, thin provisioning and single AZ versus multi-AZ. So basically these are the considerations by which you can reduce the cost. So it will be basically some kind of a trade-off. SSX for OpenZFS. Primary cost drivers are storage GB, SSD or tiering, then throughput capacity, IOPS for SSD drives, SSD cache, tiering and backups. Pricing model is provisioned or pay as you go. So there is a tiering classes which are available. And cost optimization strategies are intelligent tiering, compression, thin provisioning, quotas, single AZ versus multi-AZ. Amazon file cache. Primary cost drivers are cache storage for every GB, metadata storage GB, data transfer, cache to backend. Pricing model is per GB per month. Cost optimization strategies, you can optimize cache size and minimize usage duration. Next, AWS backup. Primary cost drivers are backup storage per GB, and there are two types, warm and cold, and how much you do restores per GB, and any cross-region, cross-account transfers. Pricing model is tiered per GB per month and pay per use for restores and transfers. Cost optimization strategies are lifecycle to cold storage, optimize backup frequency / retention. AWS data sync. Primary cost drivers are GB, how much data you have transferred, and task executions, which is in enhanced mode. Pricing model is per GB copied plus any optional fees. Cost optimization strategies are scheduling, incremental transfers and bandwidth throttling. Next, AWS No Family. Primary cost drivers are service fees per job, device usage days and data transfer out from AWS. Pricing model is per job fee, per day fee plus transfer out. Cost optimization strategies are choose right device, minimize usage delays, and you can go for commitment pricing for 1 to 3 year commitment. Next, AWS storage gateway. Primary cost drivers are storage used, backend can be S3, EBS and FSX, how much data is written for the tape and the volume, request, how many requests are there for file type, how much data transfer out, and gateway hardware or gateway VM. Pricing model is per GB per month and per GB written, number of requests, data transfer and host cost. Cost optimization strategies are S3 lifecycle for the file gateway, Glacier / deep archive for the tape gateway, and cache versus stored volumes. So basically you can move the data from these three storage gateway to respective S3, like S3 lifecycle, where you can go for Glacier or deep archive. Next, AWS transfer family. Primary cost drivers are endpoint hours, which is charged per protocol, and GB data storage, which is uploaded, downloaded, and the messages for ES2 protocol and connector calls. So ES2 protocol. So this is very specific to transfer, similar to SFTP. And pricing model is per hour per GB transfer plus the protocol ES2 fees. Cost optimization strategies are enable only needed protocols, optimize transfer volume, efficient connector use, and right size the web apps. And that's all. Thanks for watching.